Okay, this is a continuation of section 1.7 for MAC 1105. We were on part D, and we were talking about the need to isolate the expression in the absolute value bars before deciding which case you're in, because depending on which case you're in, dictates what setup you're going to use for the absolute value inequality. So we had added 3 to each side in the previous video. That got us to negative 20 on the right-hand side. We still had the absolute value expression on the left-hand side and the multiplier of negative 5. And I keep pointing out that these negative multipliers are the things that make this, the direction of the inequality symbol, change, because you're going to have to divide them off of the absolute value in order to isolate the absolute value. Then you're going to have to do it on this side as well, and that is what causes the direction of the inequality symbol to change. So this is going to change from a greater than symbol to a less than symbol, and that's because of this division by negative. So you now have a 4. Negative 20 divided by negative 5 is a 4 on the right hand side, and you have just the absolute value on the right hand side. Okay, now you know for sure that this is a less than case, because that decision is made only once you get the absolute value bars by themselves. So this is the in-betweenness case that we solved up in part A. That is completed by taking the expression out of the absolute value bars and placing it in between the negative version of that number and the positive version of that number, and solving it from the middle. So we'd have to subtract 1 in all 3 areas. That would give us negative 5, a 2x in the middle, and a 3 on the right-hand side. Then going back to the middle and continuing to isolate the x, we'd be dividing by 2 in all 3 areas. That would get our x completely isolated, leaving us with a 3/2 on the right and a negative 5/2 on the left. In order to graph that, that is red. X is all values. The solutions for x are all values between negative 5/2 and 3/2, non-inclusive of those endpoints. So the graph looks like this, where those very values are mentioned and nothing more than those values are necessary. And it's all values in between this end and this end, but not including either of those endpoints, which is why we have the parentheses. So here is the graph, and if you want to put it in interval notation, you just peel the graph away and give just the endpoints. And there is the interval solution set. Okay, moving to the last page where you are looking at graphing to find the solution. So in this first problem, we have the absolute value of 4 minus x plus 2 is less than 5. Now, yes, you could solve that as a less than case, because even if you subtracted 2 from both sides, you would still have a less than case. So it would be the less than setup. And you can use that to check your answers. But they're asking you to get familiar with your calculator and to use your graphing calculator to find the solution. So we want to see if you can interpret the picture and figure out how to deal with finding the solution that way by looking at the graph. So first thing you're going to want to do is, again, get the absolute value bars by themselves. So 4 minus x, absolute value of that expression. The 2 is now on the right-hand side, appearing as a negative 2. 5 minus 2 is 3. So if you're going to use your graphing calculator, you would call this your first graph. You would enter that as y sub 1. You would enter this as y sub 2, and you'd want to know where this graph of an absolute value, which is a V shape, I'll just kind of remind you with that V right there, it's going to be a V shape. You're going to want to know where this graph is below this other graph. The other graph is just a horizontal line, whereas the graph of this is a V. So you're going to want to know what portion of this graph, the absolute value, is below, because that is what less than means. Less than means below when you're talking, from a graphical perspective. What portion of this absolute value is below the horizontal line? So why don't we put that into the calculator? We'll toss the picture over here on the axis and we'll look for the interval of x values where the absolute value graph is below this line. Okay, so coming to your graphing calculator, let's just start from scratch. I had graphed this earlier. So for one of the functions, we're going to put absolute value. You can find the absolute value function by coming down the first column, hitting the math key, and going over to number functions. And notice that it's the first entry there. So tap enter, and it'll give you ABS for absolute value. Fill in the function 4 minus, hit the key with the x, t, theta, and n on it. It'll give you an x because you're in function mode. Close that parenthesis. So that's y sub 1, absolute value of 4 minus x. Y sub 2 is just plain old 3, a horizontal line. And we can press enter to make it absorb that second equation and push graph. Now notice that in this graphing calculator that I have not given myself much x-min. I let my x-min only go out to -2. It does go out to positive 10, so I didn't go from -10 to positive 10 just so the numbers wouldn't be so scrunched together and I can more clearly see the x values that I'm going after. Also, I only went down to -2 on my y-min, again, so that the numbers would be more spread out. And if you just want to kind of trace this picture onto your graphing grid on your handout, we have a horizontal line at y is equal to 3. And then we also have an absolute value graph, and I'll kind of do some of the numbers here. So at 1, we have an intersection point. And then also out at 7, we have an intersection point. I'm going to make this a little bit longer just so we can see the intersection point. And I can see this right on my calculator, that at 1, the absolute value intersects with the line y equal to 3, and then again at 7. Right here where it hits the x-axis is at 4. And then it hits right up here at 7 again. So it cuts through that line like that. Let's do the line like this. And what we're looking for is the portion of this absolute value that is below the line y equal to 3. Specifically, we want to know all the x values associated with that portion that's below this line y equal to 3. This is the picture of the line y equal to 3, and then this absolute value graph is y is equal to 4 minus x. So if we're looking for when is this less than this, which is what the problem asks for, again, you're looking for when the portion that's below the x values there, this absolute value starts being below this line at x equal to 1, and then it stops being below that line at x equal to 7. This x value right here. So everything from 1 to 7 shows where the absolute value is below the line y is equal to 3. And now you can solve this just to verify as a less than case, since we did a few of those on the previous page. You can just solve this as the less case, where you place this in between -3 and 3, and you will get the same solution in between 1 and 7. Let's go to the next one and also use our graphing calculator. Again, we're going to put what we see on each side as a separate function. For instance, on one side, we're going to insert as y sub 1, -3x minus 6. And then on the other side, we're going to insert as y sub 2, 4x plus 1. So this will be y sub 1. Our graphing calculator will graph that first. This will be y sub 2. This time we have a greater than symbol. And when you have a greater than symbol, what you're looking for is where is this graph above this graph? That's what it means to have. Let me just fix this up a little bit. That's what it means to be looking for a greater than situation. You want to know where this graph, and if you want to know how the graph is going to look, this is a straight line because you have x to the first degree. You do have a negative slope, so this line is going to slant to the left, while this line, this is a line also, it's first degree, but it has a positive slope. So this line is going to slant to the right. Okay, this will climb upward and to the left. This will climb upward and to the right. So if you want to graph this, I mean, you can graph it without the graphing calculator, but you can also put it in the graphing calculator and see both of these lines. One of them is going to look like this. One of them is going to look like this. And then this line right here is going to look like this. Again, you can get them from your graphing calculator. Here we go. Let's put both of them in the graphing calculator. Okay, so for y sub 1, we're going to put negative 3x minus 6. Negative 3x. If you want a negative in front of a 3, you have to use the negative down at the bottom. Oops, let's put that as the first one, because since I called it y sub 1. So negative 3x minus 6. And then for the second one, it's going to be 4x plus 1. Let's go ahead and graph that. Now you can't see enough of what's being graphed here, so I'm going to switch to a standard window. All the pre-made windows are under the zoom key. So a standard window will go from negative 10 to 10 on the x-axis, and same thing on the y-axis. Let's see if we can see more of the picture now. Okay, so it looks like right where they're intersecting is at negative 1, but you really want, and you can see that right here, that right at negative 1 is where these two lines intersect. Now you are looking for the portion where the line that climbs to the left, the one with the negative slope, which would be this negative 3x minus 6, you want to know where this line is above the other line, and that's what the greater than means. Where is this line, the one that points off to the left, where is it above the line that has a positive slope? So this is the line for x plus 1. This is the line negative 3x minus 6. So if you're looking for the portion that is the portion of this line that's above this line, this would be right here. So that intersection point is always really important. That intersection point is right at negative 1. The x value called negative 1. So at negative 1, and then for all x values that are less than that. Okay, so at negative 1 and all values that are less than that, you have the portion of this line being above the other line. So all of this is what we're trying to talk about, the x values that belong to this. Very first x value where this line called negative 3x minus 6 begins being above the other line is at the x value negative 1. And then for all these x values as you climb to negative infinity. So if you can state it like this just to begin with. It really looks like this on a number line. All the x values that are less than negative 1, they start here and then they go to negative infinity. And if you want to give the answer as purely interval style, it would be negative infinity all the way to negative 1. Again, you could solve this inequality, and the solutions that you would get algebraically would verify what we just looked at pictorially in the diagram. Okay, and that completes section 1.7.